All right, morning everyone. I put this one up again just because someone told me last week. I didn't pick up on it. Sometimes you don't pick up on it at the front, but someone was having difficulty hearing the lecture last week, just some people chatting. So please don't do that. You know I don't do a roll, so if you want to chat about stuff, it's all good elsewhere. But have a listen while you're here. Something like today's lecture, I still hope that every lecture you can hopefully walk away going, yeah, I got most of that, okay? So if you stay engaged with it, I never did at uni, I admit that. I used to just exist through lectures, go home and then learn it. And I regret it, it was stupid. So yeah, grab what you can here. I know even though it's Monday morning. What else have we got? Lectures, clinics or I keep accidentally calling them clinics. Drop-ins now. Note that I've moved one, we've now got that drop-in after this lecture because they put the lecture, they moved this time to here, so drop-ins after this one, but apart from that, every other day, 12 to 1. In the same room, MCLG 42. What else? That one. Quiz mark redemptions, okay, so we get quizzes back for the first time this week. So the redemption stuff on. Again, I'll leave it more to the tutor to explain it. And if you were with us last semester, it's exactly the same. But yes, every time you get a quiz back, by the following week's Friday, you can put them in and get a redemption, which is like a redemption form that's in the maths drop-in room behind the door, or it's on Blackboard to print out. And say you got 6 out of 10, so you lost 4 marks, you could explain answer those 4 questions correctly, explain what happened with them, and get half of that back. So you can turn 6 into an 8, turn 5 into a 7.5, and so on. So that's what the redemptions is about, but hassle your tutor or hassle us in clinic. You don't have to do them in the clinic, you can just come and ask us a question. We'll always give you the answer for it. And also with multiple choices. We've circled the correct answer or written the correct answer, but just in your words explain, or in your equations, whatever, explain the correct answer and why. Yep. What else? Room changes. You should have got this email from Peter Cork, but that name might not have jumped up as an email to get into. 2 tutes. So tomorrow morning's 9 to 10 with me, tomorrow's 1 till 2 with Ben. They've moved your rooms. Okay? Tomorrow's 1 till 2, it's only next door. Okay? But whoever's in my tute, 9 to 10, we're in GP 130 with the little swivel desks. We've been moved to 59. Okay? And your My Hub schedule should now show that. So, as of this week, we're not in this little room anymore. Okay, I think that's the announcement stuff. So, any questions at the moment? Nick. Made it back. Nick. Linear functions. Let's have a look. So proportionality, we discussed directly proportional. So we had straight lines going through the origin, okay? So that's what we did last week. We talked about units and that. This week we changed tack. We still talk about linear functions being straight line. They don't have to pass through the origin. We're also going to look on the positive side and negative side. So this week's paired in with next week. This week we're going to go to theoretical sort of stuff. We're going to look at the number plane and how do you graph things. What's a slope? Why does it look like that? And next week, we'll use that applied. Next week, that graph will mean something. It'll be speed and distance. It'll be cost to hire a trail. It'll be this, that. But we need this week just to go, okay, what's all this stuff about? So back to the number plane we introduced last week. And I said, look, last week, we didn't care about the negative side. This week we do. The whole number plane is complete fodder for us to look at. What do we care about? So we'll look at graphs like that, where it might pass through 2, 3, x of -4 and a y of 1. Down here, remember the x's come first. That green dot to the left, -1 horizontally, -2 vertically. 3 horizontally, -4 vertically. So these are the sort of graphs we're going to deal with today. Now there's 2 main things to describe it, a y-intercept and a gradient. And I'll say it up front, a lot of you are going to be, actually be interesting, I might just check. Y equals mx plus b is used to explain this, I think, mostly. I'll just write, so y equals mx plus b is a way that some people describe this. And if I'm making no sense, that's cool, I'll fix it up. Y equals A plus BX is the way we're going to do it. Has anyone recognised Y equals MX plus B as their way? Okay. This is going to bug you a bit, okay? And I admit, I'm still a Y equals MX plus B person, I'm never going to stop. I changed because our calculators that we're going to use in week 7, I think it is, call it Y equals A plus BX. And it's also, there's some logic to it. Has anyone recognised the Y equals A plus BX? Okay. All right. So this may be an unpopular change. And you can convert in your head, but bear with me and I'll try and justify again later why talk about it, A's and B's instead of M's and B's. Okay. So ignore that for the moment, and none of that may have made sense. Doesn't have to. The y-intercept of a line is purely the number where it cuts the y-axis. Okay? So this line here that I've drawn, the y-intercept is 3. It's not the coordinates of the point or anything, it's just purely, if I've got a line that cuts through there, my y-intercept is just the number 2. So firstly, we're going to introduce a y-intercept where you cut. And we're going to use the letter A to represent the y-intercept. So it makes sense, especially next week, if I'm looking at something and say, look, here's my distance and here's the time, and I say, look, I'm starting here at 10 metres and I'm doing this. My A is the 10. And it's also the starting point. My graph starts. That's where it hits, at A. So A is going to represent just the number where it hits the y-axis, the y-intercept. The only other thing, well, firstly, again, just clarifying, so the y-intercept, don't mix it with the x-intercept. There is such a thing as an x-intercept where it cuts the x-axis. We just don't use it as much. But the y-intercept to that, you could say, well, A is correct, isn't it? It's the point 0, minus 1. Yeah, it is that point. But just report as minus 1. Keep it simple. Okay, y-intercept is where it cuts the y-axis. Done. So if I know where it cuts the y-axis, it's cutting at this point, well, the other thing I can lock it in is, well, what's its slope? If I know where it's going through here and it's got a certain slope, that's my line. I've defined it. And the slope, or the gradient, it's the same thing, whether you call it slope, whether you call it gradient. We'll use the word gradient more, just because more textbooks do. But the gradient of a line is just how steep it is, and it's rise over run. Probably heard of that before. Slope is rise over run, or vertical rise over horizontal run. So there's, think of if that was a driveway. Well, that's not going to be. Imagine making a driveway like that, that's that steep. No. A driveway might be maybe 1 metre over 5 metres. We'd call the slope of that driveway vertical rise of 1 over horizontal run of 5. We could call that slope a fifth. Okay, so there's practical uses to this. I think with trains, the maximum slope trains really can handle is 1 in 60. So if you have 60 metres of train track, only 1 metre of height, that's steep for a metal-on-metal situation. We're not going there, as long as we know it's rise over run. So if someone talks about a slope of 1, it just means, well, the top of the fraction must have equaled the bottom. That's a 45-degree line. Let's pretend this is it. Say if I measured that triangle and the length of the base was 7 metres and the length up there was 7 metres, I've got myself a gradient of 1 because the rise is 7 over a run of 7, and that's 1. So just think, that's always in my mind, a gradient of 1 is just some 45-degree angle, okay, the way you're looking at it there. Now as for B, why call it the letter B? Well, again, I'm going off the y equals A plus BX thing. A is going to be my y-intercept, or I think of it like a starting point, the letter A. B, there's no logical reason to call it B. Well, there wasn't a good reason in the other way to call it M. But I just think it's like a boom gate, if that's helpful. A boom gate, okay, the slope is B. Y-intercept is A, slope is B. So that's what I'm trying to lock in here. And yeah, a lot of sources, a lot of textbooks, a lot of things will refer to gradient as M, but we're sticking with what the calculator does so we don't have to swap later. So in terms of gradients, okay, we've got some awesome graphics coming up. A positive gradient. Just think, if I'm going up, if I walk along it from left to right or bike along it, if you go up, it's a positive gradient. And that's going to seem maybe like, well, that's pretty stupid and obvious. We're going to get these wrong. Oh, you'll see later there's little traps. We'll look at that and we're going to accidentally call stuff like that negative. Same with this one. We want to know that that is a negative slope. If I walk along it in the direction I read, left to right, in the direction of the number line, if I go downhill, that's negative. Down is negative. So up's positive, down's negative. A zero slope is literally, well, okay, zero gradient, zero slope. There is no slope. Okay, so there's such a thing as b equals 0, a slope of nothing. There is no vertical rise. That run could be however long you want, but there's no rise. And a purely vertical line is infinite. As in, if I wanted to say, well, how steep is a purely vertical line? My vertical run is infinity over my horizontal run of nothing. And the whole definition dividing by 0, it's not doable. The answer is infinity. So there's the limits of our slopes. We've got positives, negatives, 0, and infinite. And there's no other, that's it. That's the list of possible gradients we could have. So here's the common ones. B equals 1. That was the 45-degree line I said. So whether it's drawn for you, whether it says, look, it passes through, remember that 0, 0 is just referred to as the origin. You could call it 0, 0. But a question might just say, look, a line passes through the origin and the point 4, 4. What's its gradient? And my gut instinct, and you might think, well, it's going through, does it fall? Clearly the gradient's 1. If I drew a triangle under it, if I drew a little triangle under it, well, my vertical rise is 1 from there to there, and my horizontal run is 1. Even if I drew a big triangle, from here to here, my vertical rise is 4 over horizontal run of 4. Still, my gradient is rise over run, 4 over 4. So a gradient of 1 staring at us there. A gradient of 2 is twice as tall. Let's find a triangle here. Well, this triangle will do. Going from here to here. I've gone vertically from here to here. I've gone 2 over horizontal run of 1. So yeah, my gradient is 2. Think of the number 2 as 2 over 1 if you want, but it's twice as steep. And so on, gradient of 2, 3, 4, so on. And remember that is just infinity. So I've got every answer from 1 up to infinity. Down that side, it's got to be a fraction. Because if I look at a triangle here, going from here to here, the run, the vertical rise is 1, but the horizontal run is 2. So you can see again, vertical over horizontal, it's only a half, it's 1 over 2. So a steep slope is 2, the middle zone is slope equals 1, you get half, I could come down to a third, I could have a slope that's tiny, like 100th or whatever, and as flat as I can go is good old 0, no slope. It's also got a mirror image. That's still related to a slope of 1, but as we said before, it's negative, okay, because it's going downhill. We just call it a negative slope, pure mirror image of the one there. Same as that one, it's a pure mirror image of the green gradient of a half, but it's a minus half. All I'm saying is if I go from here to here, first thing I do is say, well, are you a positive or negative slope? You're a negative. My vertical is 1, my horizontal is 2. You could also define it as saying, well, you said it was vertical rise over horizontal run. What's my vertical rise from here to here? Well, it's not a rise, it's a drop. So I could say vertically I've gone -1, horizontally I've still gone +2. It's the same answer. It doesn't matter what way you think about it. I admit I don't think about it the second way. I'd rather just think, are you plus or minus? And I'll just write it down, and then I'll work out the sides of the triangles. But if you want to think of it as, well, I went -1 vertically, I went 2 horizontally, -1 on 2 is still just a minus divided by a positive. What's a minus divided by a plus? It is a minus. So they're the same. Whether the minus is out the front or up the top, it's all the same thing. And again, mirror image there. That's just a -2 gradient, because of course I'm going downhill. All the dotted ones, they're all negative gradients. So there's some standards. It's nice to know that 1 and -1 are just the halfways. And not every diagram is going to be to scale. This week it'll be roughly to scale. Next week it won't necessarily be, because it might be talking about the time. This axis might be the time in hours, and this might be the distance in kilometres. So it might be 100, 200. Okay, so whereas this week it's all fairly nice and you know that a gradient of 1 is going to look pretty much like that. Well, it's not if the axes change numbers, okay? It's going to look different. It's just going to look really flat. But that's next week. This week we've still got nice and straightforward. So what's the gradient of that one? Definitely plus. Is it 3 or a third? Because it's going through there, it's going through there. Just draw a triangle and just say, I know you're positive. I know you're not 0, you're not flat. And I know it's vertical rise over horizontal run. Vertically, I've gone up 3. Horizontal run, I've only gone 1. So it is good old 3. A third will be flatter, okay? This is where an understandable trap might be able to be seen. There's a certain gut instinct there that people are going to say, well, 2 over 2 is 1, that's a gradient of 1. Do you really think that's a gradient of positive 1? No. The gradient does not equal this number over this number. Just grabbing those two numbers and putting the vertical over the horizontal doesn't work. Or doesn't work always. The technique's got to be, we've got to look at that and instantly go, you're negative. Absolutely, you're gone. I'm definitely walking, going downhill. That was here. I'm going that way. Yeah, so it's definitely negative. And my vertical rise over horizontal run, I've already decided on the sign. I don't care about the sign anymore. I just care about the triangle. Vertically, I've got a side of 2. Horizontally, I've got a side of 2. So me constructing this is, you're a minus, end of story, and you're a 2 on 2. So there's my -1 happening. Okay, my gradient is a -1. But you can understand looking at that fairly quickly. Oh, you're 1. Nope. Same error would be very easy to do here. I know it's vertical run over horizontal rise. I can see my vertical side of the triangle is 3, and horizontally it's, well, whether you want to say 2 or -2. But is that a plus or minus gradient? It's definitely plus. So don't just put the 3 on the -2. You'll get C and you're wrong. It's a plus gradient. It's 3 up, it's 2 across, so it is 3 on 2, but it's plus. Okay? So if you think why, it's just, the fact is, it is not a rule. This number on this number does not equal your gradient. You've got to separately look at the sign of it and then just look at the rise over run. That one, well, you could say, look, how accurate is this? I seem to be passing through at 1.5, so should I just use that? Well, you can, but what's the easy way to do on these is look for any points where the line goes through an intersection. Okay, because sometimes you might think, oh, he didn't say it was written to scale. Maybe it's not actually 1.5. Maybe it's 1.45, and I can't tell. But look, it's going through here, even there and there. I can use those 2 points. That's good enough. It's a minus gradient because it's going downhill. Vertically, it's 1, and horizontally it's 2. Okay, the gradient's from that. Okay, you'll find out the y-intercept is 1.5 as well. Yes, it is cutting exactly halfway through there, but if I just want the gradient, I can draw a triangle anywhere I want. I still could have drawn it there. If I was confident that that was a height of 1.5 and that was a run of 3, well, it's a negative slope. What's a 1.5 over a 3? Well, the top is exactly half of the bottom. How many 1.5s in that? 1. How many 1.5s in that? 2. Still the same answer. Now no matter where I draw my triangle, I'm going to get the same gradient. But it's just nice to do it between 2 firm points that you know. Again, this one and this one would be good. 1, and from 1 to 3 is 2. So, yep, it's a -1/2 gradient. What if we're just given, we're not told where they cut the axes, we're just given 2 points? We've got a formula for when that happens, okay? You can still do a sketch I'll answer it both ways, and depends if you're a visual person or not. Some people will do a sketch and work it out. Some people will just want to use the formula, and that's fine too. That's the formula. So if you ever asked to find the gradient of a line between 2 points, you can just plug it in that formula. Let's just look at what that formula is saying. It's if the points are defined as an x1, y1, in other words, it's like I've just walked up and said, you could be point number 1 and you could be point number 2. I know that every point is an x and a y, okay? So you're an xy and you're an xy, but you're x1, y1, and you're x2, y2. They're not squareds, they're subscripts, not superscripts. I'm not saying x squared, I'm just saying x2, x1. So, all the top formula is saying is y2 minus y1 is this y value minus this y value. In other words, the top is just finding the length of this side. All the bottom is doing is x2 minus x1 is finding the length of this side. So that's exactly what we said before. The gradient's the rise over run. If this formula finds the rise over the run, it'll work every time. And if the rise is a negative number, well, okay, my gradient will be negative. It's going to work. So the formula works every single time. You don't have to think, is it going to be plus or minus? The formula will do it for you. So let's use the formula. It's already done in the book. But the formula tells us gradient or slope equals y2 minus y1 on x2 minus x1. The main mistake in people making this is putting the x's on top. But y is the rises, okay? X is the horizontals. So if we're confident with vertical on horizontal, yeah, the y's should be on top, not on the bottom. And just resource sheet it anyway. Now, the other big mistake is going, oh, you can be x1, x2, and you can be y1, y2. Well, that's not right. Points aren't xx and yy. Points are xy and xy. X comma y, x comma y, yep. It doesn't matter which one you call point 1 or which one you call point 2. You're going to get the same answer either way. Just keep it simple. 1, 1, 2, 2. That'll do. Will work every single time. y2 minus y1 on x2 minus x1. My next warning, stop it, is going to be watch out for minus minuses. It's back to Sem 1 for those that were with us. And if not, just the fact if you've got a minus next to a minus, make sure you go plus with it. A minus next to a plus, yeah, that's working, stays minus. A plus next to minus stays minus, and two pluses make a plus. So two of the same signs next to each other will be a plus, but if they're different signs, it's going to be a minus. Let's check what happens here, just a pure subbing. It's something minus something over something minus something. The first one's a y2, which is the number 2. The second one is a y1, which is a minus 1. You don't have to put the brackets there. I just stick with a habit of algebra. When I stick a negative in, I'll put in brackets just to clarify that I can see clearly that's a minus minus going on. x2 is a minus 8. x1 is a 4. So on the top I've got 2 minus minus 1. The two minuses definitely make the plus. It's a 3. The bottom, make sure you go the right direction. Minus 4 might be a tempting mistake answer, but it says minus 8, minus 4. That doesn't make a plus, that's not part of the rules. Minus 8, minus 4 means it's like I stood at 0. I went back 8 places to minus 8, then I went back 4 places. Where did I end up? At minus 12. All the steps are backwards. I've gone heaps backwards. What's a plus divided by a minus? That's just a minus. What's 3/12 when it's at home? A quarter. Okay? There's nothing wrong if I wrote the answer minus 3/12. There's no rule that says you have to simplify. But it's probably going to be multiple choice and it'll be simplified. Okay? So minus a quarter, because I said there's 1 3 there and 4 3s there. Perfect answer. If you hate formulas, or if you're just a visual person, a sketch person, your working could have just been really crappy graph. It's your working. Okay, it can be as messy or neat as you want. 4 comma minus 1 is me going about there. That's 4, that's minus 1. The other point is minus 8 comma 2, which is minus 8 and then up 2. Clearly my diagram is not to scale. Okay, it's just my working. So -8 up 2, 4 down 1. That could be my sketch for doing this. Is it showing me a plus or minus gradient? It's definitely showing me minus. Note also we put 2 arrow points on the end just because these lines go on forever. They're not just here to here, they're just lines that go on forever. And if I was doing that, well, I would have that just said, well, okay, I know you're minus. What's the vertical rise over horizontal run? Or vertical fall, but what's the side of the triangle? How many steps do I get from going from 2 to -1? 3 steps. Oops. How many steps to go from -8 to a +4? 12 steps. 8 steps to there, 4 steps to there. So if you prefer a sketch, great, fine. The formula is normally safer, but it's your call, okay? And yeah, it depends what numbers you're given and which one is quicker to you. So that one's from the book. Here's one just for us to do. Just check both ways. First way, let's just jump into the formula. It's got really bad, what's it called? It's meant to reject the palm. I'm meant to be able to rest my hand on this. It doesn't know that. You're an X and a Y, you're an X and a Y. You can be 0.1s and you can be 0.2s. And like I said, even if I swap those numbers, I'm going to get the same answer. Y2 minus Y1 and X2 minus X1. Well, I've got a Y2 of 5 minus -3. Okay, it's that Y value minus that Y value over this X value minus the other X value. I've got the exact same sign thing happening on this one. The 5 minus -3 is a 5 plus 3. The -2 minus 2, it's not going to 0, okay? It's all backwards. -2 minus 2, I'm back at -4. I know a plus and a minus is a minus. And the 8 on the 4 is a 2. Don't accidentally halve it. No, just, you're an 8 on 4. That's a 4 on 2, that's a 2 on 1, it's 2. Just -2. And my garbage sketch, if I wanted to do it, might have been a 2 and a -3, saying 2 there, -3 there, a -2 and a +5, -2 and a +5. And if I tried to do a triangle here, hopefully I would have spotted your negative, and it's something over something. Vertically, from 5 to -3 is 8 steps, from -2 to 2 is 4 steps. Yep. Okay, either way. So there's a few ways to find gradient. Maybe you're given where it cuts. Maybe you're just given 2 points. What about that one? Passing through -2, 4 and 0, 1. Even if I just want to do this, -2 and a 4 would be here, and 0 means nowhere horizontally but 1 vertically. So that immediately at least showed me it's definitely a negative slope. Okay, if I'm passing through -2, 4 and 0, don't do anything horizontally but go up 1. Okay, at least I've got 50-50. And you'll see that if I worked it out, what's the gap between 4 and 1? It's a 3. And between -2 and 0, it's a 2. It's definitely the 3 vertical on the 2 horizontal, not 2 on 3. It's 3 on 2. Yes, it's negative. Great. So, formula-wise, I just would have said y2, that y value minus that y value, 1 minus 4, over that x value minus that, 0 minus -2. 1 minus 4 is a -3, 0 minus -2 is 0 plus 2. Yep, same thing. A single minus on the top is the same as being out the front. All right, a couple of ways to do it. So, those two things come together. If we know what a y-intercept is, and that was pretty straightforward, and we know what a gradient is, then we can talk about the equation of a linear function. So it's an equation that represents every dot on the line. This will make more sense in a sec. We'll start sketching some. And it provides y-coordinate for any x-coordinate provided. We did a bit of this last week, really. We had an equation with some numbers. Last week was fairly simple stuff. We might have had a grid like this. We had x's and y's. And we had x's maybe 0, 1, 2, 3, and y's might have been we had something like that. We had to find a k value. And we worked out that y equals 3x. So that might have been an equation from last week. That's still all we're doing. That is a linear function. That's an equation. And the equation says, you give me an x and I'll tell you what its y is. If I put x equals 2 in, 3 times 2 is 6. Yeah, that equation just tells me every pairing of numbers. Give me an x, I'll tell you the y. And it represents every dot on the line, the way we're about to sketch it. As in, all I could sketch here, 0, 0 is there, 1, 3 is there, 2, 6 is there, 3, 9 is there. Ooh, I'm getting a bit out of whack. But it's not just those 4 points. The equation represents, oh, that's horrendous. The equation represents every single point on that line. Stick in a point 1, it's got a y of 0.3. So the equation defines everything on that line. So here's an example. Y equals 2x. Well, soon, this is temporary. Okay? We won't do these boxes soon. It's just a bit of an intro to say, well, why do these things look like this? And pretty soon we won't have to bother with it. But for the moment, if you're defining y equals 2x, that means every x times 2 gives y. Okay? That times 2 is that. Minus 1 times 2 is that. 0 times 2 is still 0. 1 times 2 is 2. 2 times 2 is 4. If I wanted to plot all those points, each one of these is a point. Like that's the point, minus 2, minus 4. Minus 2 in the x, minus 4 in the y goes there. Minus 1 in the x, minus 2 goes there. 0, 0 is the origin. 1, 2 is there. 2, 4 is there. And we can see that, all right, that's my sketch. That goes on forever. That goes to all those lines, all those dots. But what we want to get to very soon is, if someone asks you to sketch y equals 2x, do you really have to fill in all the boxes? We're going to look at that and say, well, we'll get there. We won't have to. Another one, what if I stuck a minus out the front? What's that going to do to it? Well, let's just work it out manually. Minus 2 times all the x values. Minus 2 times a minus 2 is a plus 4. Minus 2 times a minus 1 is a plus 2. Minus 2 times a 0 stays 0. Minus 2 times 1 and minus 2 times 2. So it's like the exact reverse of what we had before. So minus 2 connects with a 4. Minus 1 connects with a 2. 0 is still with 0. 1 with a minus 2 and 2 with a minus 4. Okay. The last thing we sketched actually had a gradient of 2. This has a gradient of minus 2. What we're starting to allude to is, if I look at this, last week we called that a k value. This week we're going to say, you're just the gradient. I can see that whatever number is out the front of the x is the gradient of the line. That's a negative gradient, it was a positive. It's just going to be that. Let's do another one. Y equals x. Well, if y equals x, I'm not even times it by anything. Every y value is the same as the x values, so writing out my y values is just every y equals its x. If I were to graph that, a minus 2 with a minus 2, a minus 1 with a minus 1, 0 with a 0, 1 with a 1, and 2 with a 2, doesn't take long to see, okay, you're just that, you're a straight line like there. What's the gradient of that line? Before we called that a gradient of 1. Anything where its rise over run, its rise is equal to its run, 1 over 1, 2 over 2, 3 over 3, it's still working. Y equals x, it's like there's a 1 out the front. It looked like, well, you've got no number out the front. Well, yeah, you do. You've got a 1 there. We just don't bother writing y equals 1x, because 1 times x is x. So it's not like, it could be tempting to think, well, what was the number out the front of y equals x? What's the number there? It could be tempting to think, well, there's nothing there. But if it was 0 times x, it'll disappear. No. Anytime you see an x by itself, it can be a 1x. If I stuck a half in front, does that continue the pattern? Will this have a gradient of a half? Yeah, it will. Because a half of that is that, a half of that, a half of 0 is still 0, half of 1 is a half, and half of 2 is 1. So minus 2 meets with minus 1, minus 1 with minus half, 0, 0, 1 half, 2, 1. Yeah. So hopefully locking in that number that's in front of the x is just the gradient. And soon we'll stop doing boxes because it's just telling us. What if I've got a 1 plus there? Okay, that looks different. Let's just do it manually first. You might already see what's going to happen, but let's just play with it. Y equals 1 plus 2x. If x is a minus 2, that's 1 plus 2 times minus 2. 2 minus 2 is a minus 4. 1 plus a minus 4 is a minus 3. If we put a minus 1 into here, 2 minus 1 is minus 2. 1 minus a 2 is minus 1. If I put a naught into here, 2 noughts is naught. And now it says y equals 1 plus naught. And you can see the trend. They've all had it. What are my y's jumping up by? They're going up by 2s. That's going to keep happening. 1 plus 2 1s is 1 plus 2. 1 plus 2 2s is 1 plus 4. So I've got minus 2 goes with minus 3. Minus 1 goes with minus 1. Naught goes with 1. 1 goes with 3. And 2 goes with 5. And the aim is to try and see, could I have done that without all the boxes? Was there enough info just looking at old mate here? Well, I'm going to be saying that I knew my gradient was what was in front of the x. Is that a gradient of 2? You bet it is. Yeah, that's a gradient of 2. It's positive, it's 2 over 1. What did the 1 do to it? It just pushed it up by 1. More accurately, that number there was the y-intercept. It's like I went to my y equals 2x boxes and added 1 to every number. And if we push it up by 1, then it means instead of cutting through at 0, it's cutting through at 1. So this is where we're heading. I can look at y equals 1 plus 2x and I can see two things. First thing I can see is it cuts through at 1. So there's a point. Next thing I can see is it's got a gradient of 2. I'm heading towards a shortcut. Okay? Again, all these slides are temporary ones. 2 minus a half x. Well, my guess here is, from what I just said, was I reckon, well, the y-intercept is 2 and the gradient is negative a half, which means it's not negative 1, it's not steep. It's something like that. That's my rough idea of what it's going to look like. Let's test it. Put a minus 2 into here. Minus a half times minus 2 is a plus 1. Put a minus 1 into there. Minus a half times minus 1, well, that's a plus a half. 2 plus a half. Put naught in there, I'll get a 2. Put 1 into there, I get 2 minus a half. Put 2 into there, I get 2 minus 1. If I graph them, minus 2 goes with 3, minus 1 goes with 2.5, naught goes with 2, 1 goes with 1.5, 2 goes with 1. Yeah, it was telling me good info already. You got a y-intercept of 2, and you're going down a negative gradient. It's only a half. It's not steep. So now, we'll leave those boxes and... Sorry, Bianca. Oh, it's just a time thing, not a correction. I can add up, okay, good. Alright, so now that we've seen those boxes, let's check. How do we do it without them? Here is the guts of today, okay? And when we talk about this week and next week, I started off saying, oh, you know, y equals mx plus b. Some people knew what I was talking about. This is our thing, y equals a plus bx. And all that's saying is, when a question's going to say, what's the equation of this line? We're going to say, every straight line is in the form y equals a plus bx. If you can find a y-intercept, which is a, and work out my gradient, which is b, you can work out the equation of the line. You can look at a picture and write down the equation, or get an equation and write down the picture. Let's try it. There's an equation. I don't want to do the boxes. I just want to use the info given here. Now, the first bit of info, the number that is by itself, that's not times in the x, the number that's by itself. We'll get to a point soon. It doesn't have to be on the left because would you agree that y equals 2 plus x and y equals x plus 2, they're actually the same thing, annoyingly. Because if I'm saying 2 plus 3 and 3 plus 2, just because something's on the left, something's on the right, doesn't give me a different answer. So I can't just lock in and say, whatever number's on the left is my y-intercept. It won't always be, but I can lock in whatever number is by itself. It's not times an x, it's just by itself, is your y-intercept. Done. There's a point. That 2 told me the y-intercept. The gradient is whatever's multiplying the x. What's that x really being multiplied by? Just a 1. It's not written there, but it can be. So the gradient is 1. Now that info that says, I'll just write it down. So that told me the y-intercept is 2 and the gradient is 1. Think of any gradient as a fraction. The number 1 could be written 1 over 1. That just tells me for every vertical move of 1, go horizontally 1. So vertically 1, horizontally 1 is telling me the next point's there. I can do more if I want. 2 points is enough to join the dots. But it's saying for every vertical move of 1, it's got a horizontal move of 1. I could have gone backwards. You can see what's happening there. That has a y-intercept of 2 and a gradient of 1. That's it. Much nicer than bothering with the boxes. Alright, so the standalone number is the y-intercept. Call an A. Imagine like it's where it starts from. Y equals 1 minus x, alright. I'm not going to let the minus put me off or anything. The number that's by itself is a positive 1. If it had a sign next to it, I'll take that into account. If I said minus 1, I'll come down here, but it doesn't. My y-intercept is 1. So there's my first dot. I know it's cutting through the y-axis at 1. The gradient, what's this x being times by? Well, it's a negative 1 this time. Alright, so that means my gradient is negative 1. And again, if you want, just put it over 1. And you think that's vertically, I've gone down 1 for a horizontal run of 1. Vertically, down 1, horizontal run of 1. Down 1. Okay, I see what's happening here. That's what y equals 1 minus x looks like. Y-intercept of 1, check. Gradient minus 1, absolutely. Alright, what's the next one giving us? The number by itself is minus 2. Easy. Straight to there. The gradient is a minus 2. Everything goes over 1, so I'll say it's gone down 2 vertically for every 1 I go across. Down 2 vertically for every 1 I go across. And okay, I've run out there. I can't go down to, well, I couldn't, but you know, down to there. But I can repeat that pattern. You can see if that pattern's L-shaped like that. Then I can see the others. Yes, rulers come into the course here. It's not a have to. The sort of sketching we're doing is pretty rough. But there are times when, and I'll just provide a grid like that. If this is in the mid-semester, you're getting a question like this, it's not just graph paper, it'll be a grid like that. The numbers will be on there, the axes will be in there. And if you just didn't have a ruler, I mean, this would be fine. Okay. Yeah, great, awesome, okay. But if you want to carry a little ruler, we're going to have rulers written on the front of our exams to say rulers are in. But there's my pretty line. Okay. Okay, mixing it up a bit. That gradient looks a bit different, but it's fairly understandable. I was turning all the other ones into fractions anyway. First with the y-intercept, easy. The number by itself is a 3. Okay, let's put a dot at 3 at the y-intercept. Its gradient is positive 1/2. That means it's going up. Vertically 1 for every 2 horizontal. Just go to that point, vertically 1, up, 2 horizontal, I'm there. Again, that's enough to join the dots. But if I want to look, so it's down across 2, down across 2, down across 2, I can just make sure that I'm getting through everything right. That's y equals 3 plus half x. Hopefully the point's been made. Standalone number y-intercept, the number multiplying by the x is my gradient. We haven't left it, okay? It's going to get, there's repetitive bits, but this just is the bit that's saying don't rely on left and right, okay? Yes, we can write a plus bx, but bx plus a is still technically the same thing because addition, you don't have to put left and right. So if someone's asking me about y equals a half x plus 1, it's not a y-intercept of half. They've just swapped them around. The number standing by itself, including its sign, is the y-intercept. So my y-intercept is plus 1, and my gradient is whatever's times in by the x. It's a positive a half. Well, positive half is still vertical and horizontal, means for every 1 I go up, it's 2 horizontally. For every 1 I go up, it's 2 horizontally. Okay? Purely, it's not left-right. Standalone number is your A. Your multiplier of x is the B. So that's why we call it y equals a plus bx. No matter what you give me, the A, the y-intercept, stands by itself. The B is hard up against the x. And here's another form. If we got asked to sketch 2x plus y minus 3 equals 0, it's called the general form. We don't go into that. There's certain formulas you might have used at school, talk about general form, put in the general form. We don't care, okay? But a little bit of algebra, if we could get asked to sketch that, and we need to know that if we can put it into this form, then it's like every other question we've ever been given. If I can turn that into a y equals, we can do that. If I've got 2x plus y minus 3 equals 0, my aim is I really want the y by itself. Just bit by bit, get rid of the other junk. Okay, it doesn't matter what you go first with, but I've got a 2x here. Clearly I don't want it there. I just want a y on the left. So how do I get rid of a 2x that's just sitting there? Subtract it. I'm not dividing it because it's not multiplying anything. 2x is sitting there, not doing anything to anyone else. Subtraction. So if I take 2x away from both sides of the equal sign, that is, that's gone. That gives me y minus 3 equals 0 minus 2x. I could write 0 minus 2x, but 0 minus 2x is minus 2x. It's like 0 minus 3 is minus 3. I don't have to write the 0 there. Last step I've got to do is, well, I don't want the minus 3 there. Let's add a 3 to both sides. That got rid of that. Now I could write the plus 3 on the left or the right. Makes no difference. I'm going to write on the left because that's the form I'm going for. But if you'd left the minus 2x there and then written a plus 3, it's still the same answer. I'm just trying to get, it wanted the y equals a plus bx form. So this equation, which someone's asked me to do, which looks very foreign to me, a bit of algebra and I can see, all right, you got a y-intercept of 3, you got a gradient of minus 2. Doable. Okay. So that one's already out of the book. Okay, here is just a few examples I've put in. We'll have a break after this page, just to see the different ways this is going to come at us. So if y is the subject of the formula, and most of it will be, then we want to work out what the gradient is for these questions. And the gradient is always multiplying the x. What's the gradient of that line? It's just a plus 7. What's the gradient of that line? -2. Done. Remember, grab the sign. Every number owns a sign to its left. So, yep, that was multiplying the x. Gradient of that line. 1.6, whatever's next to the x. Y equals 2x. It's a 2. Out of interest, what's the y-intercept of that line? It's 0, because what's the number there? Is there a plus 7 there or a plus 9? Nope. It's like there's a plus 0 there. Y equals 2x. We should go for 4. We knew it had a gradient of 2. It's got a y-intercept of 0. So it's just a steep line through there. What at y equals half x? Gradient is a half. Press too quick. Those two could look, y equals x on 2 can look off-putting. People want to call that a gradient of 2. But it's not being times by 2, is it? What's that x really being times by to get to look like that? Half. Okay? if I want to get an x, times it by something until it looks like an x on 2, just think of that. It'll be it. What's even easier to see it? If you've got a solitary x, just stick a 1 in front of it. That makes it a bit clearer to see a half, doesn't it? If it's just a single x on a 2, that x has copped a 1 on 2. It's being multiplied by a half. So those two were the same question. Y equals 2x on 5, what's its gradient? What did the x get multiplied by to become 2x on 5? 2 over 5. Okay? It's just literally the fraction you're looking at. That x is like 2 on 5 times an x is 2x on 5. Yep. Gradient's just 2/5. Okay, stick a 10-minute break in there.
Question. How come we don't use y equals mx plus c?
Because our calculators, I'll say it again, but our calculators in there, we're going to use them later to work out, we're going to put some data in there, we'll get it to give us a gradient and a y-intercept. Its gradient is called b and its y-intercept is called a. The first year I brought this in, I stuck with good old y equals mx plus b and we just swapped when we did that one. I know, it's still going to be annoying a bit, but it's worth it. It's going to be worth it. I wasn't a believer, but I am a believer now.
Okay. I have another question.
Okay, I'll just get the timer going. There, there, about 9 now, and do it. The other question.
Just curious. How old are you?
Wasn't 4.
Really?
Yeah. I was in my prime for the when I hit 47.
That's not even funny.
Why? Why do you... Okay, I don't know. What are you doing?
So we do sounds good.
I mean, it's all like this grab. I mean, if you're not, what do you... So, it's just, I mean, at the moment it's focusing on just the lecture notes. It's all.
Yeah, well, I haven't watched the lecture. But they
worship.
Yeah, they were
Yeah.
so I plan to running it. I'll be recording, so I'll be having an issue.
Yes, and also week 2 is up for degree 4. I'll start with week 1 and week 2 and so this week started last week. Week 2 is yeah, I can tell. What do you want to do for it at the moment?
Is that right? Sorry, Brian. That's true. I've been there. Like, I've been in childhood. I've been put up to me with last one.
Gotcha. Oh, okay. Cool. Excuse me.
I'm going to Hawaii during
Okay, when to when?
I'm going during this semester, so I missed out on the first quiz, the first test, and then the first quiz back. Because I go from the
They literally kept saying I should keep
from the 9th of September to the 7th of October.
So does that mean you miss week 8?
Yeah, I'm just the mid-semester.
Okay.
So it's only 11th, and I'll be gone.
Okay. The mid-semester covers work from week 1 to week 6. So the question, I mean, you can... Is this a holiday that's booked before?
For like 2 years, because it's a cruise as well.
So you're going to be able to live with our first semester, but it's going to be fine. I'll just ask you to upload a photo or a receipt for the document. Your choice, the most important choice is join the mid-semester early.
see if you can be okay. Because I was talking to football. I was talking to him and said, oh, they're going to get you to do it after.
Oh, no way.
Yeah,
It's your call.
yeah, no, I'd rather do it early, so don't worry about that.
No. Just put in your thing, and if you ever put in the documentation, just look, just email me. Okay, we'll just obviously get you to do it like the week before, you know, just same time, but just get you to do it.
Thank you.
How are you? I saw your name pop up. Did you swap for something else, or you just?
Yeah, because I was doing the
It's not for you. Okay. Oh, you're doing 50. Okay. Okay. Gotcha. Okay, you missed that. You put that in the week 13. And for this week, so you can skip it if you want, because you're probably ready for it. I mean, it's your call. I don't mind. You can. Okay, see, yeah, you're in my class. Anyway, it's your call. If you're not ready for it, try and hand the piece out, so, yeah. And we'll put it in when we're ready as well. If you are ready for it, you'll get out of it. But apart from that, just, the same old. Check out the lectures online. It's not too bad a start. We've got the calculators. I think most people so far have found it not too shabby. So, yeah, all good.
Do you understand that?
Mm-hmm.
I don't understand that.
Okay, well that U really means a union. Generally it's not a U, it's this symbol. But also it means union, which means the probability of A and or B happening. Okay? So it's like if we said, let's put in this, if A was equal to, do you know cards? You know what's on cards and that? If A is getting a heart, no, let's make it simple. If A is getting an ace, or B, how do I get a B in the cards? No, it doesn't matter, it falls apart. And a B is hearts. What's the probability of getting an A and or a B from 52 cards, one selection? And that's when I look at, see, I've also got to say this is for mutually exclusive events, so I've just gone into
That's what stopped me.
Okay. So my example was bad. I'll come back to that. Probability, if we're talking about rolling a die.
I've also actually got that here.
Okay. Yeah, exactly. If the probability of A is rolling a 2, and the probability of B is roll a 3, what's the probability of rolling a 2 or 3? It's just saying it's the probability of a 2 plus the probability of a 3.
So say because the die is like 6-sided,
Yep.
you've got pretty much like a 1 in 6 chance of
Yep.
rolling in either 2 or
3. Yep. And a 6 plus a 6 is 2 6. Or a third, it doesn't matter. But the reason why that was cool for this formula is because there's two formulas. This is when they're mutually exclusive, as in you can't do both. If you roll a 2, you can't also roll a 3. That formula is for when both can't happen.
I do remember, I had this lecture this morning, I do remember that actually.
Okay. There's a second formula, see, that says if they both can happen, it's a probability of A plus the probability of B, all it's the same, minus the probability of both happening. So if both can happen. And my example there is, we'll finish this one. What's the probability of getting an ace? How many aces are in a pack of cards?
Always do.
Yep. Bin. It's just outside the door for some reason. 4 and 52. Plus, how many hearts are in a pack?
That's a good question.
Because there's 4 suits. 50 divided by 4 is 13, so there's 13 hearts, 13 diamonds, 13 clubs, 13 spades. But the technicality is it possible for you to get an ace and a heart?
No. Yes, there is.
How many cards are an ace and a heart?
There's only one.
Yep. The ace of hearts is the only card. That's where that formula comes in. It says you can still add them, but take away the overlap. Because 4 of those cards, 4 cards satisfied this. One of them was the ace of hearts. 13 cards were hearts, but one of them is the ace of hearts. I counted the ace of hearts twice. I can't do that. That's why we subtracted that. Now I might have gone overboard. If they're not showing you this formula, ignore that. But if you're wondering about what's this formula saying, it's only saying this. That if both can't happen, probably that, it's and or that, is just add the 2 individual probabilities together.
No, I actually understand.
Cool. Alright. Okay.
Thanks for that.
No worries. Okay, so the next bit, you see at least fortunately we're going to carry on talking about the same concept. This y equals a plus bx is going to be everything. Got the question again, and I do understand it. For the y equals mx plus b is out there. Why again? Why are we doing this? Why are we changing the letters? Because we're going to use the calculators in week 7. We're going to put some points in there, and it's going to give us a line of best fit. In other words, it's going to give us a gradient, and it's going to give us a y-intercept. Any of your calculators out there are going to call the y-intercept A, capital A, and it's going to call the gradient capital B. So we don't have to get to that point and then swap the letters around. We're just starting with it. This course is y equals a plus bx. A is a y-intercept, B is a slope, and that's... I've gotten out of the habit of screwing up. I think I do consistently say the right thing now. So, finding the equation of a linear function. So a question might say, what's the y-intercept? Fine. What's the gradient? Fine. But more commonly they'll say, well, what's the equation of the line? If they're saying what's the equation of the line, it means if I can find the a and the b, I'll give you the equation. Because the equation of all straight lines is in the form y equals a plus bx. But tell us what the a is and tell us what the b is. Okay, so we've got some different scenarios here. If the gradient and y-intercept of the line is known, well, here's an example. Someone walks up to us and says, well, it's an odd example, find the equation of the line with the gradient 4 of y-intercept of minus 3. They've done all my work for me. As soon as they say find the equation of the line, that makes me think y equals a plus bx. If only I knew what the a and b were. They gave me the a and b. The gradient, or the y-intercept is minus 3, so I'm going to replace the a with a minus 3. The gradient is 4. And the question's over. Okay, so if you get given a gradient and a y-intercept, as long as you're put in the right spot, the gradient's against the x, the y-intercept's by itself, question's over. Okay, that is the equation of a line that's got that gradient and that gradient. And I know, in other words, there's y, there's x, I know it looks something like that. I know it passes through minus 3 and it's got some sort of steep gradient. Just a rough concept. Yep, fine. It's called y equals minus 3 plus 4x. The second scenario is if you know the gradient and a point it passes through. They didn't give you the y-intercept. Like there's an example. We still want to find the equation of the line. We know its gradient, good. But we don't know its y-intercept. Now, I could draw a really neat sketch with some really accurate boxes and I could... I'm not going to do it that way, but let's just pretend for a sec. If I had some graph paper and I said, look, here's the point 2, 3, and it's got a gradient of minus 2, and if I drew it really accurately, I could read what that number is, and then I found my y-intercept. But we're not here to do that, okay? We're not bothering to graph these things accurately, we're just going to do sketches. I want to do it algebraically, because even if I did it that way, I'm not sure. I might have moved a bit, I might have I might be inaccurate. let's just look at the algebraic way. As soon as it says find the equation of the line, boringly, that's it. We're doing this again. Y equals A plus BX. But I want to know what A and B are. Well, gradient's minus 2. Sweet, I've got my B. The gradient is a minus 2. So at least I can say that. Y equals A minus 2x. But I don't know what A is. But that's the equation of the line that passes through that point. That means that point must work. X equals 2 and Y equals 3 must make this equation work. So really I've got everything I need to find out. I knew my B was minus 2, so Y equals A minus 2x. Now if I just sub in an X of 2 and a Y of 3, I'm going to be able to work out what A is. Let's just chuck it in. A Y equals 3 equals A minus 2 times X. X is a 2. It's going to answer it for me. Order of operations says do this multiplication first. 3 equals A minus 4. Next bit of algebra says to get rid of that minus 4, let's add 4 to both sides. 7 equals A. That bad sketch I did before, it said it's something like that, said that, look, it's up here somewhere. Yeah, it is, it's 7. Okay? I'm not doing it by a sketch, but just by plugging everything I know into it, it told me the y-intercept was 7. So to finish the question off, I've just got to rewrite, but instead of writing A, I can write 7. The equation of the line is y equals 7 minus 2x. Okay? So again, with all of these, as soon as it says equation of a line, I'm going to think y equals A plus bx, then I'm going to think, well, what have you given to me? If you give me A and B, you've made life easy for me. If you've given me only B, but also an x and a y, again, it's like the interest formula. I equals PRN. They give us all the info but 1. We can find it out. Same thing's happening here. Let's look at the third example. If two points the line passes through a node, in other words, it says find the equation of the line, we'll tell you 2 points it's going through. Okay, so you haven't given me the y-intercept or the gradient, you've just told me 2 points. Well, I know that 2 points, I can find a gradient, because we've got a gradient formula, B equals y2 minus y1 and x2 minus x1. So if you've got 2 points, I'll find the gradient. If I know the gradient and a point it goes through, it's like question 2 all over again. So it's all doable. Let's look at the example there. I'm fortunate in this one, it's only given me 2 points, but what's special about 0,1? It's on the y-axis. That's telling me the y-intercept is 1. All right. Bad habits. Okay, instantly, I can look at that picture and say, stop it. The y-intercept is 1. I also need a gradient. I could use my formula. If you're going to give me a sketch, I'm going to scribble on it. You give me a sketch, and I'm just going to do that to it. Technically, it's a right-angled triangle. Let's not get all Pythagoras. What's the vertical rise here? Well, that's 1. And it's easy to mistake these two. It's easy to think, well, that's a height of 4. It says 4. No. 4, 3. 4 horizontally, 3, up. So what's the vertical distance here? It's only a 2, from 1 to 3. What's a horizontal distance? It's from 0 to 4. So if I said my gradient is, it's a positive, because left to right I'm going up, and it's a 2 on 4, or in other words, just a half. That's all good. That's in the sketch. You might not like the sketch method. Just go back to the formula, where I say B equals y2 minus y1, on x2 minus x1, and just call that point xy, call that point xy, again, whatever numbers you want, but 1, 1, 2, 2 will do. And that formula tells me, do the 3 minus 1 on top, on the 4 minus 0 on the bottom. 3 minus 1 is 2, 4 minus 0 is 4. Either way, I found A is 1, B is a half, and always finish off answering the question. Find the equation, Well, the equation is y equals a plus bx. The a is a 1 and b is a half. Y equals 1 plus half x. That's my answer. Okay, my y-intercept was easy. My gradient, either way I found it. Check another one. This time, they haven't given me a y-intercept. I could have a rough guess, but I'll be wasting time. So let's just look at, well, I know one thing I can find easy, and that's the gradient. Again, whether you do sketch or not, it's your call. That's the point 1, 3. That's the point 4, 9. Hence, I'm confident my gradient is a positive. Left to right, I'm going up. Vertically, 9 minus 3 is 6. Horizontally, 4 minus 1 is 3. Okay. Or, if you're a formula person, doing the y2 minus y1 and x2 minus x1, that's when you'll do the 9 minus 3 on top over the 4 minus 1 on the bottom. It's exactly what I did anyway. Okay. And I still don't know the y-intercept. But that's what we happened in question 2. If we know the gradient and any point it goes through, I can pick either point, it doesn't matter. If I'm trying to find the y-intercept, I know that y equals a plus bx. And let's just choose this point. This will do. The x equals 1, y equals 3. I'll get the same answer if I said x equals 4, y equals 9. Any old point that the line goes through. But the 1, 3 will do. Y is a 3. A is, I don't know yet. Plus B is a 2. And X, you're not going to do it, are you? Just erase. Ooh. B is a 2 times an X of 1. That's me subbing everything I know. I knew an X, a Y, and a B. Yep. 3 equals A plus 2 ones is 2. Subtract 2 from both sides. 1 equals A. The picture wasn't to scale, but do I agree that that sounds about right, that y-intercept could be 1? Yeah, I'm happy with that. If I said my y-intercept was 4, I'd go, I think I've made a mistake somewhere. But I knew if it's 9 there, 3 there, I knew my y-intercept was down here somewhere. And there's my final answer. Y equals A plus bx becomes y equals A is 1 plus 2x. The equation of that line is y equals 1 plus 2x. Yes, it's got a y-intercept of 1. Yes, it's got a gradient of 2. So the next 2 examples are actually exactly the same as those. I probably could have skipped the book ones. But let's just do them. Here's one of those ones that looks like, oh cool, the gradient is just plus 2. But it's not. It's not just the 4 and the 2. My gradient's minus. I'm not going to bother with a formula for this one because it's such a nice sketch that says I've definitely got a negative gradient. Vertical 4 over horizontal of 2. My gradient's minus 2. What's A for this one? Just the y-intercept. Cuts through at 4. So that's a pretty quick question to answer. Gradient minus 2, y-intercept 4. Hence, y equals A plus bx becomes y equals an A of 4. It's a plus b, which is a plus minus 2. You're not going to be marked wrong if you wrote plus minus 2x. Okay, if you wrote that, you're not wrong. But what happens between a plus and a minus? They're both right, but all you got to think is, if it's a plus gradient, you'll have plus 2x. If it's a minus gradient, you'll have minus 2x. Okay, and does that look like y equals 4 minus 2x? There's the 4 minus 2 stick. That looks, I'm pretty happy with that. All right, what do you got for us for the next one? All right, an equation of that. Well, straight out, A is 1. The y-intercept is 1. Great. The gradient is positive. If I walk left to right, I'm going up. That's a positive gradient. Vertically, in this triangle here, I've got a height of 1. And how far from minus 2 to 0? Again, that was actually pretty quick to answer. Just please don't fall for the minus half answer. Gradient, it's a positive. y equals a plus bx tells me, well, replace the a with the number 1, replace b with a positive half. And again, do I agree with that answer? Y equals 1, a positive half? Yeah, it's looking good. I hope it's looking like this topic. Yeah, it's not too bad. Guess another one then. Okay, I've put lots of trap answers in there. I want to get some sort of confident answer, or if anyone wants to get rid of any answers, can anyone see any answers like it's not you? Any that there's something about it? I'll get rid of D very quickly. The y-intercept is 1. Lock it in. A, B, C have y-intercepts of 1. D has... No. What about plus minus? Should this be a plus or minus gradient? Minus, yep. Because it's going downhill. It's a minus gradient. Get rid of C. Now, okay, the only opportunity is it upside down or not? Vertical over horizontal says vertically I've got a distance of 1, over horizontally I've got a distance of a half. We've got calculators, but that's asking 1 divided by a half. How many halves are in 1? 2. So, yes, it is this one. Again, that's not a have to. You can go straight to the calc. But yeah, it's a gradient of 2. Its vertical rise or vertical drop was 1 compared to only a half, which means after a full one, it would have dropped 2. But that'll do. And we knew it was minus because we're looking at it. Okay, so and hopefully that ties up. 1 minus 2x, that looks good. Okay, these are the ones that we already had ones like it. I'll just do the sketch one here because it's a nice sketch. But again, I'm going to mark my x, that's 1, 2. I'm going to mark my x and y coordinates so I don't mix up which is which. It's x of 4 and it's y of 5. So now it's clear to me. The gap vertically is 3, the gap horizontally is 3. What's the gradient going to be? It's just going to be a 1. Because vertically I've got 3, horizontally I've got 3. 3 on 3 is 1. Yes, it's positive. So gradient is a positive, definitely. Vertical rise over horizontal run. So my gradient's just 1. I don't know my y-intercept, but I know that I can chuck anything, any straight line into this form. My b, I know. My a, I don't know. But I've got an x and a y. Pick whatever you want. That'll do. X equals 1, y equals 2. That point will do the job. So replace the y with a 2. A is still I don't know. The b is a 1. And the x is a 1. So 2 equals a plus 1 times 1. 1 times 1 is a 1. Subtract 1 off both sides. 1 equals a. Again, I don't mind looking back at my sketch, not for scale, just for a really stupid answer. Do I agree my y-intercept could be 1? You bet I do. 5, 2, yeah. Yep. If it said 17, I'll doubt myself. A equals 1, B equals 1. Well, that's one of the nicest we've got. Instead of writing y equals a plus bx, it's just y equals 1 plus 1x. Again, if I wrote 1x, that's no problem. But we know that 1x is just x. So y equals 1 plus x would be the main way we'd write it. Not incorrect, leaving the 1 there. Still okay. Okay, so finding gradients, sketch or formula, finding y-intercept, definitely formula. Okay. Last one here. I can see where it cuts the x-axis. It's the y-intercept I care about. I don't know what the y-intercept is there. So this time I might just go for the formula. I know that's an x and a y, and I know that's an x and a y. You can be the 1s and you can be the 2s. The formula tells me to subtract y2 minus y1 over x2 minus x1. So that's a minus 4 minus 0 on the top. And the bottom will be a 6 minus minus 2. So minus 4 minus 0, nothing happened to it. It's still minus 4. A 6 minus minus 2 is a 6 plus 2. I've got a minus divided by plus overall. Yeah, it's a minus. 4 and 8, a half will do. I should have said before, whether you write as a fraction or decimal, doesn't matter, makes no difference. A gradient of 0.5, a gradient of 1 over 2, they're the same thing. Now, it's the same as the previous question. I don't know my A, so let's chuck everything in. Let's pick on the point, this one will do. That tells me when x equals minus 2, y equals 0. So let's replace the y with a 0. The A is I don't know, the B is minus a half, and the x is minus 2. 0 equals A minus a half times minus 2. Well, minus a half times minus 2 must become plus, and a half of a 2 is 1. So if I take 1 away from both sides, that means minus 1 must equal A. I found my A, I found the B. So instead of writing y equals A plus bx, I can write y equals A of minus 1, A of minus 1, B of minus half. Yeah, that's us. Y equals minus 1 minus half x. Again, I don't mind looking back and saying, do I agree with the minus 1 y-intercept? Well, that's 0, that's minus 4. Yeah, that's reasonable. Okay, enough of them. There's one thing we haven't done yet, which is, now this is where we're heading. We just want to sketch linear functions. You might have a question, like I said, where we'll put a grid in there, mostly next week. And you'll be moderately accurate with it. Not the world's most accurate, but you'll, count boxes and be fairly accurate. Most of the time what we're going to say is, look, a sketch will do. Just a sketch. And here's our methods for just sketching a linear function. Now firstly, what is a sketch? Compared to graph a linear function and sketch a linear function, graph is, I've got a full grid, I've got the numbers, and I'm being accurate. Okay? What's a sketch? This is a sketch. A sketch says, I still call it a y and an x. It might be a line that's going through like that. That might be a 1, and that might be a 1. That's a sketch. A sketch doesn't need any points drawn on it, it just needs x-intercept and y-intercept. If it touches the lines, you know it, that's a sketch. This is a sketch. Maybe that's minus 3 and maybe that's 2. That's a sketch, okay? So it's axes, it's labelled, and you just label if it cuts here and if it cuts here, great. So, if I want to determine the x-intercept, as in I've got something here, y equals 3 plus 2, say it was the graph y equals 3 plus x, and someone wanted me to sketch it. Well, the first thing I know that's easy is the y-intercept. Here's the y-intercept, I can see it, y equals 3. The Sandler number is 3. What I don't know is the x-intercept. Now, the easy way to find the x-intercept is to determine the x-intercept is to let y equals 0 and solve it. Why? Well, the x-intercept sits on here. If I pick this line, what's the y-coordinate of this point? It's not up, it's not down, the y-coordinate is 0. Here, the y-coordinate is 0. Here, the y-coordinate is 0. It's always going to work. The x-intercepts are when the y is 0. Because the y is not up, the y is not down. You'll always be able to find your x-intercept when y equals 0. You'll also be able to find your y-intercept when x equals 0. It's just this reciprocal thing they've got. That if I'm saying that, I'm going to follow this. If I want to know the x-intercept, just let y equals 0. Okay, I just chucked y equals 0 in the equation. How do I get that x by itself? Subtract 3 from both sides. Minus 3 equals x. That's my x-intercept. If I know my y-intercept, because here it was, my x-intercept, because here it was, just join the dots. Ugh. There's my sketch. I've sketched y equals 3 plus x. Does it make sense? A y-intercept of 3, correct? What's the gradient of y equals 3 plus x? Just a 1? Yeah, that looks right. That's a gradient of 1. What's happened there? Rise over run of 3 over 3? Yep, that's exactly what we wanted. So let's do another. We'll get back to that. Example, sketch that function. Okay, it's written in a way that's not the y equals form. But what we can do is say, well, I really don't care. Because we know that we can find the x-intercept when y equals 0, and we can find the y-intercept when x equals 0. I don't care even if you give it to me in this weird format. I'm just going to do two substitutions. Okay. First I'll let y equals 0. What does that do? Instead of 2x minus y plus 4 equals 0, that's 2x minus 0 plus 4 equals 0. All I did was sub in y equals 0. Alright, well that's gone. That just says 2x plus 4 equals 0. Alright, I better take a 4 off both sides. 2x equals minus 4. Get rid of that times 2 by dividing by 2. Sketch half done. X equals minus 2. Okay. Now, the other part is just let x equals 0. Alright, go back to the original function. 2 times 0 minus y plus 4 equals 0. Well, 2 times 0 is 0. Minus y plus 4 equals 0. I could take 4 off both sides because I had a minus y there, fine. I've got a plus 4, so I'll take 4 off both sides. Instead of minus y, I want y. We just multiply both sides by minus 1. In other words, if I times u by minus 1, you become positive. If I times u by minus 1, you become positive. I've done everything I need. Now this sketch, I know it's not a scale. I normally try and make it roughly close. That's 2, that's 4, normally if I'd drawn that thing earlier. But it doesn't matter, it's a sketch. You could do it massively out of scale if you wanted. Oh, okay. But that's a sketch. It's got a y-intercept of 4. It's got a x-intercept of minus 2. Totally valid. So there's a quick way, no matter what you've asked me to sketch. Here's another one. What we're going to do is x equals 0, find a y equals 0, find an x, join the dots. If x equals 0, 0 plus 3y minus 6 equals 0, I just want to get that to a y equals. Don't care about the 0. I can add a 6 to both sides to get rid of the minus 6. That gives 3y equals 6. And see the answer start staring at you. Divide both sides by 3, I've got a y equals 2. Okay, so there's my y-intercept. Let's find the x-intercept just by letting y equals 0. X plus 3 times 0 minus 6 equals 0. 3 times 0 is 0, don't care about it. So x minus 6 equals 0 is all it really says. Let's add a 6 to get rid of the minus 6. 0 plus 6 is 6, alright. My sketch just needs to have an x-intercept of 6 and a y-intercept of 2. Here's my sketch. I'll try and be a bit more accurate. Y equals 2, x equals 6. So if x is way out here at 6 and y is 2, let's make it about there. That's moderately accurate. Y equals 2, x equals 6. Give it a line through it. Sketched. That's my sketch of that function. For fun, I might just rearrange that function to y equals and see if it makes sense. Instead of x plus 3y minus 6 equals 0, I'll get rid of that x. I'll take x off both sides. Oops. Now I'll add 6 to both sides. Divide both sides by 3. 6 on 3 is a 2, minus x on 3. This is not an essential bit, but I'm just looking at it. If I rearrange it, y equals 2, 2 y-intercept, I agree. A gradient of negative a third, that's exactly what it is. It's negative, 2 on 6 is 1 on 3. It's just another way to confirm I got everything right. This one, more likely great. It's already in the form I want. This is the main predictable sort of question we'll get. And part of it I can do from the very start. It might be on the right instead of the left, but that's still my y-intercept. My y-intercept is the number 3. All I need now is an x-intercept. And it's the quickest way to do an x-intercept. Just let y equal 0. When y equals 0, my equation becomes 0 equals 2x plus 3. Yep, this is going to be the quickest way to find my x-intercept. Is 0 equals 2x plus 3, I want the x by itself. Let's at least take 3 away from both sides. To get that x by itself, let's divide by 2. That's it. Call it minus 1.5 if you want. Minus 3 on 2, minus 1.5. Minus 3 on 2 will do. Sketch done. Y-intercept was given to me. X-intercept came pretty quickly. And does it look right? Does that look like something that's a gradient of 2? I know I haven't drawn it to scale, but if I had to work it out, I'd say yes to the plus. 3 on 3 on 2 in the calc would spit me out of 2. That's exactly right. Okay, so sketching these functions, hopefully not too bad. Now notice the table of values method, we can always resort back. It is true that if you're ever in doubt, you can do a box there and work it out. It's a much slower way to do it. But sometimes, like if I had to graph y equals 3x, initially I could go, oh God, I don't know what you look like. Just remember at any time you can say, well, 3 times 0 is 0, 3 times 1 is 3, 2 times 3 is 6. And you can still plot it, 0, 0, 1, 3, 2, 6. And pretty quickly you can see, all right, I see what you look like. But that was graphing it. If someone asked me to sketch y equals 3x, it's actually really easy to sketch. Because our definition of sketch was just do a rough sketch and write down where any intercepts are. As we said before, it's like there's a plus 0 there. This is going through a y-intercept of 0. So it's passing through here, it's got a gradient of 3. It's a pretty simple sketch. That'll do. Sketch y equals 3x, done. I don't have to mark other points on it. I don't have to mark the y-intercept because it's going through the origin. X-intercept, it's going through the origin. So that one, 2x plus y equals 0. That looks really bodgy. I could either chuck x equals 0 to find y-intercept, y equals 0 to find x-intercept. But look what would happen. If I plugged x equals 0 in there, it'll give me the answer y equals 0. And of course, if I plugged y equals 0 in, it'll give me x equals 0. So all that's telling me is, damn it, it's going through the origin. Okay, what's this gradient look like? Let's just do that simple thing, the y equals form. Take that 2x away and take a 2x away. If I take a 2x away, y equals minus 2x, hopefully by now you can look at y equals minus 2x and say, you're going through the origin, and you've got a gradient of minus 2. There's your sketch. You can say, well, how does that sketch differ from y equals minus 3x? It really doesn't. It's a rough sketch. But I drew a negative gradient going through the origin. That's my sketch. Yeah, there's some odd ones out. And here I want to try which are exactly the opposite of what my gut instinct will think. What's the name of them? Think of this line, y equals 5. Horizontal lines have a gradient of 0. If you think of y equals mx, stop it, y equals a plus bx. What do we know about horizontal lines? Yeah, its gradient is 0. B is a 0. If that b is a 0, 0 times x is 0. All horizontal lines are in the form y equals a, where a is just the y-intercept. Well, look at that I've plotted there. This is a line y equals 5. Because if y equals 5, it doesn't matter what x is. When x is minus 2, y is still 5. When x is minus 1, y is still 5. When x is 0, y is 5. Why do I think that's the opposite of the gut instinct? Because I'd like to think horizontal lines were x's. Because the x-axis is horizontal, and it's called x. But y equals lines are horizontal. Why? Because there's no gradient. The gradient is 0, So so if I'm asked what is the name of, say, here's y, here's x, and it's passing horizontal passing through 4, it's literally just called y equals 4, because no matter where I sit on that line, the y is 4. The x could be anything you want, but the y is always 4. The opposite must happen as well. If horizontal lines are y equals, vertical lines must be x equals. Everywhere I go to on that line, the x coordinate is -2. The y is 100, the y is 10, the y is 5, the y is -50, don't care. So vertical lines are x equals, and horizontal lines are y equals. So, anyway, there's more on that in the worksheet. All we finish off with today, there is very little different in this last bit. It looks like, okay, where are we going here? This is the more useful part of what this is about. We'll do more on this next week, but if you were to draw two lines on the one diagram, unless they're parallel, they're going to cut. And often that point where they cut is going to be the only thing we care about it. It's like if it's some profit graph, it's like, okay, I'm spending this much, or we're making this much. Where do they meet? Where's the break-even point? That sort of stuff. We're not going far into it, but it could be really critical to find out, well, where do these two lines meet? Now, we can do it algebraically and graphically. Algebraically is just simultaneous equations from last semester. And the beauty is it's not, a lot of people didn't like those elimination ones where you had to go vertically. The only ones we'll come across algebraically is these. The y equals form. And I know you still may be new to this course this semester, but if we're being asked to solve, clearly that's a linear equation. That's a linear equation. If you're getting asked to solve it algebraically, that means don't draw a picture, just find out the answer. Well, if y equals this and y equals that, we just let them equal each other. Okay? If y equals this and y equals that, these must equal each other. They have to. So then, are we able to solve something algebraically like this? If we stuck to the main method, we say, well, I've got 4x's here and 2x's here. Let's take these 2x's away from both sides. If I take 2x away from here, it's gone. Take 2x away from the right, 4x comes down to 2x. Then let's get rid of this 3 by subtracting it. That becomes 2 equals 2x. Let's divide both sides by 2 to get the x by itself. 1 equals x, or x equals 1. How do we then find out the y? Chuck x equals 1 back into either one. Doesn't matter which one you chuck it into. If I chucked it back into here, it would be y equals 5 plus 2 1s, which is 5 plus 2, which is 7. If I chucked it here, it would be y equals 3 plus 4 1s, which is 3 plus 4, which is 7. So either way, when I chuck it in, I'm getting x equals 1 and y equals 7. So algebraically, it told me the point of intersection is that. Let's again look at what would y equals 5 plus 2x look like. It would have a y-intercept of 5 and a gradient that's pretty steep of 2. If I was to plot y equals 3 plus 4x, its y-intercept is only 3, but it's steeper. And what did we find out the answer was? The point 1, 7. So even without a sketch, yes, we can solve it. But could we do it with a sketch? You bet we could, because we've done this. Y equals 5 plus 2x has a y-intercept of 5, and for every 1 across it goes up 2. That's why it looks like that. The y equals 3 plus 4x hits the y-axis at 3, but then for every 1 across it goes up 4. And there's the point. That's finding graphically. What was the answer? 1, 7. Exactly the same as we found algebraically. Well, obviously. So there's our coordinate. So let's look at this one here. It's our last example. Find both algebraically and graphically the point of intersection of them, if it exists. Sometimes they don't cut, but we won't ask about them. Okay, so algebraically, all I've got to do is let them equal each other. To be honest, I prefer to do them algebraically. If I was given a choice, and often we have said that, look, here's two equations, here's some graph paper, do it whatever way you want, algebraically or graphically. I'd rather just say, well, if y equals this and y equals that, fine. This equals that. Then, well, my normal method is wherever there are more x's, let them sit there. 5x is bigger than 3x, so let's leave the 5x there and subtract 3x from both sides. That'll get rid of that. Minus 4 equals minus 6 plus 2x. Then I'd say, well, let's try and get the x by itself. Let's add a 6 to both sides. Add a 6. What's minus 4 plus a 6? Well, that's a 2. 2 equals 2x. Divide both sides by 2 leaves me x equals 1. They'll always be nice answers, okay? If x equals 1, just chuck that back into whichever equation you want. The first one will do. Y equals minus 4 plus 3x is y equals minus 4 plus 3 times 1. Minus 4 plus 3 is minus 1. So there we go, algebraically I found the answer is x equals 1, y equals minus 1. Otherwise written 1 comma minus 1. They're both the same. 1 comma minus 1 was my answer. X is 1, y is minus 1. But if I wanted to do it graphically, well, I know my answer is going to be 1 minus 1. Y equals minus 4 plus 3x. Go to your minus 4. Put a dot there. Plus 3x. It's like for every 3 I go up, I only go 1 across. 3 I go up, 1 across. 3 up, 1 across. Okay. There's a y equals minus 4 plus 3x. The other one is y equals minus 6 plus 5x. So it cuts down here, but it's steeper. So I start with a point, and its gradient is 5 on 1. So for every 5 it goes up, it's 1 across. We've already seen the answer. What's the answer? They cut at 1 comma minus 1. Okay? If that was asked of you, you'd get the graph paper, you'd get the numbers, it'd be exactly like what's in your notes at the moment. The question is, can you find the y-intercept and jump up the correct number of boxes? Y-intercept for the other, jump up the correct number of boxes, and just read where they meet. That's it. We're done. All right. Catch you in the tute or next week.
To you for now. I'm just going to Louis and going to get something to eat.
Nice, catch you.
Hey Dave, I'm not going to be here on Thursday in the tutorial, so do I just go get like a sheet thing from the office and fill it all out, or?
You can, or you just send a different sheet for the week.
No, I've got to go home. Like, I've got to go home.
Okay.
So,
Well, there's one to Savo if you want it, but it's your call.
yeah.
Yeah. But if you want to fill in a form so you're able to sit the quiz a week 13,
Yeah.
you can either get a form for the office or you can do it all online if you want.
Oh, okay.
And you can
Like,
upload
that's
it.
for every class in the day. Or like if I can change them around to different days.
Hmm.
It's just I'll work part like all day tomorrow and Wednesday.
So that's your call. So if you sneak one in, then it's exactly the same.
Yeah.
If you can't do it, there's that paperwork.
Okay.
Or online.
Yeah, alright.
I have another one of those questions where I've almost got the answer.
Yep, gotcha.
This is from last week. So that's the question.
Okay, the Thompson varies inversely. So you've got what? Yes, and then something's going wrong.
That's what I got.
Okay.
That's what the answer is.
With that numbers that close, it could just be a rounding thing. But let's just check. Just a bit of this. So if we've got varies inversely. So T was equal to K over S. So T 2.5 equaled K over 70. We didn't. Yep. So we've got 140 and 35. So did you get K equals 175?
Yeah.
Yep. So you got T equals 175 on S, and for this one, decreases by 40%. So if the speed was, let's see what it might be. Anyway, if the speed was 70 kilometres per hour,
So go 42
well, if you do, times 0.6, so that's 42 kilometres per hour. Yep, agreed. So T should be 175 on 42. Yeah, totally. If that's what you've done, then you're correct. I'll check on that. That shouldn't be a rounding error either. That's just... Okay, no, that's a bad in the answers. What are we? We're proportionally 11. Oh, no, there's the answer. There it is. You're both right. So you said 4.16 hours.
Yep.
That's correct. 0.16 times 60 is 10 minutes.
Oh, is it? Oh, okay.
So it's the same answer.
Oh, okay.
4 hours, 10 minutes is 4.16 of an hour. Okay.
That's freaking out.
Oh, I like it when it all works out nice. Yeah.
Thank you very much.
No worries. And the other answer made sense on Blackboard?
Yeah.
Yep, sweet. Okay.